I think the recording is on. Welcome everyone to SQL Friday. This is episode 100, which I think is pretty cool. I did not really anticipate it to last that long when I started in just early in the pandemic, May or something in the pandemic. Heini, this is your first time on SQL Friday, and I'm super happy to have you here. And hey, well, we see the slide. You're going to talk about less clicking and more coding about infrastructure and stuff. I could try to do an introduction of you, but I think you'll have to do one on your own. And I think I just have to tell Lara, you have your camera on, and it seems like you use that camera to scan invoices or something. Maybe Lars, sorry, not Lara. So Lars, please turn off your camera if you wish. Thank you. Heini, welcome. Who are you?
Thank you. I have to say I'm really excited to be here, and it's quite cool to be here for the 100th episode. It's quite mind-blowing. 100 is a big number. So congrats, Magnus. Great that you've got this rolling and it's going so well. I am Heini Ilmarinen and I actually live in Finland. So I am calling in from our offices here in Tampere. And I'll do a bit more intro as we get to the session.
All right. So if you're good to go, you can start.
Yeah, I think I am. So what we're going to be talking about today is how can we get our data platform development to be nice and easy without having to go into the Azure portal and manually poke around things, and take it more to this code-driven way of doing things. So less clicking, more coding, Azure data platform development for using infrastructure as code. And I played around with whether to have the title as less clicking, more sanity, or less clicking, more coding. But all the time, I'm not sure if you get more sanity. Occasionally, yes, but at times it feels like, oh my gosh. So like anything, it's not a thing that will solve all your problems, but it will definitely ease many that you might have in being able to replicate your environments, for example, and be consistent across your configurations in your environments as well. So as we're talking about Azure side of data platform development, the first thing that might come to mind from infrastructure as code might be something like ARM templates. And ARM templates have been around for quite a long time, as long as the current model of Azure has been around. And even a few years ago, it was already said that, well, ARM templates are the way to go, and it'll ease your work with your Azure resources. And me, among others, went ahead like, okay, ARM templates, let's get to it. And very excitedly started to try to figure out how to do this thing. And well, let's just say that it was not a smooth beginning, and I never grew to like ARM templates that much, I have to say. And the nice thing is that the idea is still good. You create a configuration of your resources, and based on that, your resources get created. So you would, for example, define your Azure Data Lake resources, whatever you need in your configuration there, as well as any other resources that you would need on your data platform. And the nice thing is that we have other options than ARM templates now. We have things like Terraform, which is the main topic of today. But there are other options as well, like Bicep. I will mention about it shortly in a bit as well, but there's Pulumi and so forth. So there is many options that you can actually use nowadays to do the same thing that are way easier than ARM templates. So to get our head wrapped around how to work with Terraform, we're going to start with an introduction to infrastructure as code, just to get the main terminology down and understand what are we talking about. Then we're going to get started with Terraform and see how easy is it actually to get going and how do you create your first resources. And then we'll talk lastly about a little bit about the workflow of things. How do you actually work once you're in this setup of having code instead of going into the portal? And how do you work with a team? So, as mentioned, I'm Heini Ilmarinen. I work for a small Finnish company called Polar Squad as a DevOps consultant and also the Azure lead. So I also take care of our Microsoft partnership. I am a data platform MVP as well as an MCT. And as Magnus was saying beforehand, last week there was Alexander from Knee Deep in Tech, and this week it's me. I think that wasn't entirely intentional, but we happen to be in 2 consecutive weeks here. And my favorite topic is definitely about architecture, and infrastructure as code for me is how do you make that architecture come to life in an easy way and a repeatable way. And my background is in mathematics, and then I decided to hop into the IT world and have stayed here. And as you might have noticed already, I am a bit of a serial doodler, and you will see quite many illustrations along the way. So let's get started with an introduction to infrastructure as code. And Magnus, just to double check, there's an hour total, so I'll leave some time for questions, discussion in the end. Yeah, perfect.
I'm not super conservative on time. If you need 70 minutes, I'm going to be okay with it.
All right. Let's see, I think 60 minutes is perfect, and I'll leave some time for questions in the end, but if you do have any questions in between, feel free to write them in the chat. I'll keep an eye on that, and I can take some questions on the go as well. So if you have anything that comes to mind, just write it in the chat. So let's start with infrastructure as code. What is it really? So in the core, infrastructure as code is some kind of definition where you give configuration parameters and then the values for those configuration parameters. So essentially you just say, hey, I want to create this resource and these are the parameters that I want to create it by. And based on that configuration, what appears are your Azure resources just magically. And then there is a lot of differences between tooling, whether the configuration language is easy or difficult, and kind of what is the syntax of it. And as mentioned, we have quite many options. On the Azure side, things started from ARM templates. But as said, they're not the easiest. It is JSON syntax, so that even makes it already a bit puffy in the look because we have all the curly brackets, etc., that we have to figure out. Plus, there was other complexities with it as well. And so with ARM, there has come out this kind of a, I don't know what is the right way to call it, but a tool called Bicep that actually behind the scenes generates the ARM templates for you from those Bicep templates. And the Bicep syntax is much, much more simple than ARM. And definitely if you're thinking between ARM or Bicep, yes, go for Bicep. It will keep your sanity much, much longer. And then we do also have third-party options for the configuration as well. What we're going to be talking about today is Terraform. There is the benefit with the third-party options that they often work with other platforms than Azure as well. So if you have multi-cloud environments or even hybrid environments, you might be able to use the same tool for different things. There's no tool yet that does so that you just say, hey, I want a SQL database, and it would know to create that in any cloud just by that. So you do have to make different configurations anyway. But the idea is that you could use the same tooling and be familiar with the same syntax all the way through your different platforms. And then there is another option as well, which is Pulumi. Pulumi has been kind of up and coming and gained some, now I lost the word, but it has gained some momentum. And we'll see how far it goes. But there's some issues of Terraform that Pulumi kind of addresses, and we'll talk about those in a little bit of a later point. And it does bring some benefits to the table compared to Terraform. What is common to all these different languages is that these are declarative. So you just state what is the end state of the resource that you want to achieve. That is the main idea. You don't actually say in what order you need to do things. Compared to, for example, the different scripting tools that we have, like Azure CLI or PowerShell. there you need to, for example, know that, hey, you first need to create a, let's say, a disk for a virtual machine, and then a network interface card, and so forth. And then after you have all those components, then you create the virtual machine. So you need to kind of say what is the process and the steps you have to take. So today, when I'm talking about infrastructure as code, I mean the tools that are not, scripting languages, but are declarative in nature. The other quality that infrastructure as code has is being idempotent. And what that means is that however many times we run that configuration, it will always end up in the same result. And it doesn't matter what kind of resources are already there or what aren't, it will just get you to the end state. And again, the difference with some of the scripting languages is that you might need to then build into your code, like checking, is the resource already there, and then do something if it is, and do different things if it's not. So that is really beneficial if you think about infrastructure. You want to really, the desire is to get to a specific state. And if we talk about the benefits of infrastructure as code, these are kind of like what I have seen through using infrastructure as code as the main benefits. And one of them is documentation, in the sense of like your Terraform code will have the documentation of the configuration of your resources, as long as you only used infrastructure as code. So you don't have to go poking around the portal and figure out like where is the setting displayed, etc., to find out what the value is. You can just look at your Terraform configuration and find out, okay, this is what value I have set there. So it really documents the configuration level settings that you have in place. But of course, it might be beneficial to have some overview architecture pictures to get a better sense of how the Terraform resources, for example, link together, and how networks are built and things like that. So it's not, of course, all encompassing, because it has that configuration level detail. So getting the big picture can be a little more difficult in that sense. The second benefit here is, of course, the repeatability. So if you have dev, test, prod environments, with infrastructure as code, it is much more easy to have that replication between the environments. And even if you have a situation that something goes wrong and you just want to take a copy of your environment for a temporary testing scenario, you can do that. You just take your latest configuration files, deploy it with different parameters, and off you go. So it really makes that easy and much faster than in the situation where things aren't exactly right. You try to start clicking through the portal and like, what is this setting and what is that setting? It will take much more time to do it manually. And the last benefit really is being able to use version control. And that means that even our infrastructure is version controlled when we use infrastructure as code, because it's just files. So it enables us to use Git and make sure that we have a track of our changes to our infrastructure. So if we notice that we make a change to our infrastructure and everything breaks, we know what is the cause, because we can look back at the changes that have been made. And it also means that we are able to roll back to that previous state and revert the change that made the issues. Because, well, on the data side, of course, the issue could come from the data level as well, but sometimes it could be introduced on the infra layer as well. So it at least makes the infra layer tracking a lot more easier. If we talk about infrastructure as code in terms of Azure, we do need to understand a little bit what goes behind the scenes in Azure when you deploy your resource. So the model that Azure is based on is called Azure Resource Manager. That's where the ARM template, ARM portion comes from, Azure Resource Manager. And what this means is that behind the scenes, there is these resource providers for each of the different resource types that you have in Azure. For example, for storage, for SQL, Data Factory, there are many, many different resource providers. Some are more for just like one resource. And then we have something like networking that feels a little like it contains multiple resources, but I guess it's more multiple capabilities. But anyways, we have these different resource providers for different resource types. and they define what kind of operations can you do on it, what are the required parameters, what things can you update without the resource being recreated, etc. So these resource providers define what you can do with them. And they all have these APIs that you can use to call them as well. And when we deploy a resource, our calls get routed through the resource manager to those resource provider based on which resources we want to create. So if we want to create a SQL server and a data factory, then those requests to create those resources go to these two particular resource providers. And we had many different tools, of course, that we can use to create resources. And one is the portal, where it pretty much directly communicates with the Azure APIs. But we also have SDKs, which are software development kits. And this is also what Terraform uses behind the scenes to be able to communicate with Azure and then to create these resources. And we can see this structure of the resource manager and the resource providers also in the templates that we can find for our resources if we go to the portal. And this is essentially what a ARM template would look like as well. This is what we need to create if we use ARM templates. But it is this capability that actually enables us to even use infrastructure as code, that there's a programmatic way to check for the state of the resource and what is its current configuration, as well as change that state when you call the API of the resource provider. So this is kind of then how it stores that configuration of the resource behind the scenes in Azure itself. All right. With that, we start to have quite a good understanding of infrastructure as code in general, and particularly how it works with Azure and what happens behind the scenes in Azure when we deploy resources. So now we're going to start shifting a little more towards, well, how does this all work with Terraform? And we can go back to this previous picture that we looked at a little bit and see, like, how does then Terraform link into this? So in the beginning, you probably are maybe one developer who starts to create infrastructure as code files. And what you need to get started with Terraform is you need to have Azure CLI, and then you need to install Terraform. And what the install in this case means is that you download the package and then you add that to your path. That's all you need to do. So it's not like an installation package that you get or anything like that. You just download and add it to your path. And after that, you are ready to create your Terraform files, which we'll look at in a moment. And then you make your configuration in that file, and then that gets passed through the SDK to the REST API. And Terraform is actually built using Go. So it uses then the Go SDK to communicate with the Azure Resource Manager. But this does have a little implication on Terraform and how it works, because the SDKs don't get published until things are in general availability in Azure. So you might realize that, well, some things are in preview for quite a long time, that could cause a little issues. And you're right, there is no support in the regular Azure RM provider that we're going to be looking at today to put in preview resources. But there is this new AZ API provider in Terraform as well that you can use. And that is what would enable you to also create preview resources with Terraform. So in those cases, the Terraform then goes kind of directly to the REST API and just passes in the information that is needed for those preview resources. But it's kind of good to note that there's no such a sophisticated support on the Terraform side for the preview resources, as for example in Bicep, where you have all the capabilities available from day one. So that is something that you will then need to evaluate. Is it an issue or is it not? It depends on your scenario.
I think it's maybe worth though that even if you can do things with Bicep, you won't get the tooling for them before
That's
later.
very true.
So it's not going to be super easy. It's kind of like writing the ARM template yourself.
Exactly.
You have the tooling and auto completion and stuff like that.
That is very, very true. Actually, a good addition. And it's kind of the similar in Terraform, like you can create the preview resources as well, but then you need to have kind of the configuration in a specific way yourself, and then you pass that on to Terraform and it will take care of the rest. And of course, with preview features, we also have to remember that they might radically change when they go to GA as well. So our configuration might go completely again anyways, so it might not be such a huge worry about that. One of the aspects that is different in Terraform than, for example, in Bicep or ARM templates is that it stores a state of what state are your resources in. And it stores that in a state file that by default gets landed locally on your laptop where you create the Terraform files, but it's also able to, you're also able to have it as a remote state, for example, in Azure storage, or there's also Terraform Cloud and other different options that you could use. But state file is something that we need to figure out how to handle, and we'll get back to the details a bit later on. But the question might be that we have these different options for infrastructure as code. So why should we use Terraform? One of the benefits for me is that the syntax is really easy and it's super fast to get started. Like the learning curve isn't super big. You have to learn a few basic things and then you can get going. If you do get to more complex environments going forward, yes, there's some tricky things to do with Terraform, like for each loops and conditionals and things like that, but there are patterns that repeat. But kind of the basic skills that you need to work with Terraform are quite simple, as you'll see today. The other benefit is that it supports many providers, and I can maybe give an example that might be relevant working as a data professional. So for example, if you work with Databricks, you would use the Azure RM provider first to create the Azure Databricks service itself. But if you want to also manage Databricks and its resources within Databricks, kind of the compute and everything within Databricks, you are not able to do everything with the Azure RM Databricks provider, but there is a separate Databricks provider that you can use, and that enables you to go deeper into the configuration with your Terraform files. So that is a very huge benefit of Terraform, that you are often able to go a little further with your configuration than what you are able to do with, for example, Bicep or ARM templates, because they, of course, support only things that are Azure resources. So even like creating a Azure SQL, we then need to log into the SQL and create users and so forth. But on the other hand, with Terraform, you could find there are SQL providers that you could use and go a little further along. Of course, you have to think about how far do you want to go, but there is the option and the flexibility to add these different providers to help you set things up. So the provider is really defining what kind of resource are you managing with Terraform. So whether it's Azure Cloud resources or, for example, Databricks resources or AWS Cloud resources. So there's many options there that we can work with. Then also there are very frequent updates in Terraform. I think it's like the average is about 6 days with the Azure provider in Terraform. So it is constantly updating. It does bring the other side of, yes, it's updating, so you need to ensure that your files also keep up to date with any changes that might come. Oftentimes there's no breaking changes, but over time it will start to accumulate. So at some relative pace, you do want to keep up to date with that. All right. And then I think one last point that I didn't even write out here is that the fact that Terraform is really widely used, both in the context of Azure as well as other clouds and other resources. So there's a lot of community support, and most of the time the issues get resolved quite fast. So there's a really big community that you can get resources from as well. All right, I think it's time for us to get kind of hands in and start our first Terraform deployment. We'll start with a resource group. Yes. And start with a storage account. And let's check on the time a little bit. We're going to see how far we get, but maybe Azure Data Factory, SQL, and so forth. So there are many things that we can do here. And to get started with creating the resources themselves, we have to first set the provider. That is the very first thing that we need to do. And then after we get the provider set, then we can create our first resources. All right. I
have a challenge for you, by the way. Can't you also include a managed instance in the demo? You have 34 minutes to go.
I'm sorry, the managed instance won't be up in that time. So
is remember, it like 8 hours or something?
Yeah, exactly. So of course, with Terraform, it has to work within the boundaries of the resources themselves. So it won't get ready during the demo. Yeah. Oh, how fun.
Yeah.
Very, very fun. And let me get the right screen here for Terraform. I realized I kind of have these a little funky on my, let me get this here. So I have just my Azure portal open so that we can check that all our resources get into the right place. And then I also want to show you the Terraform documentation, because that is a nice place to have kind of as a reference point, especially when starting with creating your first Terraform configurations. It is kind of the place that you want to come into and keep open and check back to with the, like, what kind of syntax do you need and so forth. And this is the documentation of the Azure provider. And then with each of the providers, there's also this kind of nice, use this provider checkbox here. So we can grab this as a starting point for our files. And we're just going to hop over here. And we're actually going to create a new file over here. And let's call it main.tf. So Terraform files have this TF extension. And within my Visual Studio Code, I have also added a Terraform extension, which makes it recognize, oh, it's a Terraform file, and helps us with the writing of the code as well quite a bit. So let's grab whatever I copied from the documentation. So it really has this block, Terraform block, for what are the required providers. It has the version of the provider, and this just helps ensure that you are always using the same provider when running the files, and it's the provider that kind of your file configuration matches. As said, the versions change quite rapidly, so it's good to have either a tight versioning, so you give just one version that you can use, or a more open that, hey, the minor versions can change, but the major version should be at least this. So that would be one option. And so in the provider block, we do have to add this features block, which can be empty. This is where you can set things like, hey, always use this subscription ID, and many other configurations to have your Terraform act the way you want it. There's also settings for purge deleting key vault values, for example. So if you're using Terraform to create and destroy resources rapidly, then you might have to also consider some of the purge settings. All right. So this is actually all that we need for the Terraform configuration itself to get started. So this just defines which of the providers are we using. And let's just right away add our first resource, because then we will be able to see that something happens. And as you can see, it right away so shows kind of the list of Azure resources that we have available from Terraform. So they all start with the Azure RM, and let's say I want a resource group. That was enough to get that. So we create this resource block, we tell the resource type that we're creating, and then we give it a reference within Terraform. So we can call it RG, or one kind of a practice that is used in many places is when there's just one resource group, for example, you just say this because we know it refers to that particular resource group. But for a resource group, we know that we need a name. So it does help to be familiar with Azure concepts and know which kind of variables you need with different resources. So we need also location. What should I get? I did not write that correctly. Switzerland North. I think that has been working recently. Sometimes with the subscriptions, I have some restrictions. So we need a name and a location, and with resource group, we do not really need anything else. And to get started with a Terraform provider, we first need to initialize it. So that is the very first step. But it is something that you don't have to run every single time. It is only when you update your providers or you add a new provider or the very first time that you run Terraform. And with that, you can see that here there is a new file that has appeared. So this Terraform lock HCL. And this pretty much keeps a set of hashes that are associated with the specific providers that you have in your configuration. So it just keeps track that the providers are correct. And then it will show that there are changes if you change the providers or the provider versions. And then there is also this Terraform directory, and there you can see it kind of downloaded an exe file that is that Azure RM provider there. So it actually kind of pulls it for you. All right, so I have done the init. So the next thing that I might want to do is plan and see, I cannot write today, Terraform plan. The trick here is actually for myself. I have an alias for Terraform, so I only need to write TF. Normally, I thought I'll write it all out so I don't people don't go writing TF on their own. And but I no longer apparently know how to write Terraform in its entirety, it seems. So, so the plan is going to take a moment. But here we can see it says that, hey, I will add one resource. It is a resource group that will be created, and it shows what are the configurations associated with it. So that's all in the plan now, since it's only one resource. And then if we're ready to make the changes, we can run Terraform apply. And the apply will actually include also the plan step. So once you get more comfortable, you can just even run apply directly. And then if you realize in the plan that there's an issue, you can still revert it. Though note that for example, if you set Terraform to run in pipelines automatically, you would need to have some kind of approval in place. And then actually, if it's not something where somebody can come in and type yes at this point, you would need to have the apply with this auto approve flag on. So we know it's just the one change with the resource group, so we can just say, yes, please make the changes. So it will take a moment to create the resource group, not long at all. It will, of course, always depend on what Azure resource are you creating, and that will kind of set the stage of how long will it take to create it. So this shouldn't be too long at all, just a few moments once it starts creating. Yeah, creation complete. So now we can go back and verify and see, hey, resource groups, where are you? And the thing is that oftentimes it takes a little moment longer for it to show up here than it does for Terraform to say, I'm ready. And that is just that the Azure user interface comes a little behind oftentimes. Even if you create a resource group in the portal, if you navigate to the resource group list and don't go with go to resource, you might not see it in the list. So you will have to give it a few moments to have time to catch up a little bit. There it is. So we see our resource group, but we see that, no, it doesn't have yet any resources because we only have the resource group that we have created. All right, so easy. That was just creating our first resource group. Yes, it's just a resource group, in this case, the first resource, but that is kind of the main principle. We choose what kind of resource we want to create, set the resource block in the Terraform file, set the resource type, and then give it a name within Terraform and put in all the required configurations that it needs. So let's create some more resources. And while we do that, let's also check how to use variables in our configuration, because that is something that we'll come across quite soon, quite early when we start working with Terraform. All right. So let's come back to our Terraform files and let's create a new file. So actually, Terraform doesn't care what the files are named when you run the Terraform commands. So whatever directory you're in, so in this case, I'm in the SQL Friday directory, and it will just look around like, what are the .tf files that are in this directory? And then it will pull all that configuration together and then create the plan and apply based on that, all the files that are there. And it doesn't even matter whether it's main.tf or data.tf or whatever the file name is. You can name it whatever makes sense in your project. But it's more like a logical organization for ourselves so that it's easier to find the resources that we are looking for. So again, we want to create a new resource. So let's start with a resource block. We need to find our resource type. So let's say we want to create a storage account. Let's do this syntax this time. And let's give it a name. Let's do that. And then it requires a location. And let's give it a resource group. All right, so should we now just write the resource group name here manually again? Or maybe we have some better way to do it. And actually, the Visual Studio Code is giving us a hint already. So it's giving the reference of Azure RM resource group.rg. And that is how we're able to reference other resources in our configuration. So it's the resource type, the name of the resource, and then whatever property we want from there. So if we want the resource group name, we just grab the name from there. So this is how we can make a reference to another. So this first part is the resource type. So if we check, it's the same as here. And then the name here was the RG, and then we have that there. And then we just grab the name from that resource group. So that way we don't have to manually write the name of the resource group anywhere. We can just reference the resource group itself. And maybe a good idea would be even to have the location referenced from the resource group, because probably we want also the location to be the same as for our resource group itself. All right. And if we want to make this storage account a data lake, we need a setting that is HNS enabled. So the hierarchical namespace, that's what it references to, and we can put in true. And I think we actually have some other properties that are required, but now I forgot them. No, that's not it. All right, whenever you forget, what to go to is the documentation. So in the documentation, if we go here, this is the main documentation. You can go either scroll through the list of the different resource types that are here and find storage. There we go. And then we can see all the different storage related resources that are possible. And we can find storage account. That apparently hasn't clicked out. Can I hide it? Yes, thank you. So in addition, I can see a sample of how the configuration works here. So oftentimes these samples are a really good starting point. And with some cases, there are several samples that we can look at. And then in addition, it also have a list of the required resources as well. I mean, the properties that you need to set, and then the optional ones. So actually, those were the only required ones. Oh, never mind. Account tier is the one that is required in addition. Normally, they are actually in the order that all the required ones are first, but for some reason, it has the account kind here as an optional one. That is interesting. So, but with that, we can have those here as well. Let's start with that. Let's go with locally redundant storage. Then we need the account here. Oops, being too fast with the entering. Oopsies.
And I think you got the access tier instead of account tier.
Exactly. That's what I was looking at as well. Account tier, yes, please. And account kind. Oh no, what's happening? What's happening? There we go. So it does, like with this, you can see that it does help to be familiar with the Azure terms. What you need to note is that sometimes like what are the allowed values might not be the same as what is visible in the portal itself. So it can be beneficial to come and check what are the correct formats from here. So let's do the storage v2 and then standard in this case. And now I forget which one is which. Tier is standard. And storage v2.
And you have a small typo on the property. It's account tier now. So some extra characters.
Oh, thank you.
No problem.
Yeah, thank you. That's why it's nice to have a second set of eyes. All right, so now we have the entire storage account configuration in place as well. And I actually do need quotes for the name, otherwise it won't recognize that. Let's do actually a little change here. Let's do that for the name. I might have used it already elsewhere. And let's be kind of bold here and let's just run Terraform apply directly and see what happens. So I wanted to take these few first resources a bit slow, and then I have some templates that we can copy over and get going a little faster. So the same thing, we want to ensure that the changes that we are putting into place are going the correct way. And then we want to ensure that we check, is it the correct thing? The fun thing with Terraform is that you also often get to see behind the scenes that, wow, a storage account has a lot of properties that we most of the time don't even think about when creating it from the portal. So then it can be nice to take some time to really check through and see what's available there. Keeping an eye on my battery, I realized it's going a little low, but it should be sufficient for the next 15 minutes.
So if you disappear, we know why.
Yes, I'll try to keep an eye on it to make sure. I'll grab the charger if it comes to it, but it should be fine.
Well, so waiting for this to create, I might add, Heini has at least done, I think you're still doing like full day learning sessions about Terraform. So I did on the pre-con day before Data Saturday last year. So if you see Heini do it anywhere near you, it's totally worth spending a day learning Terraform with Heini, because it gets you a bit further than this hour. So
yeah, exactly. And it's easy to like fill a day with Terraform content. There is so much to learn. So again, we can see that one has been added. What I want to point at right now is that now we see the Terraform state appear. It actually appeared already after creating the resource group. So this is really what stores what kind of state have we left our resources with the last time we ran Terraform. And it is, of course, possible that this state deviates from what is in the resources if somebody goes and pokes around manually. That is, of course, not what we want. We want everybody to then do everything with Terraform. Some changes Terraform can kind of see and will give you a warning like, hey, this has changed. And then you can act accordingly. But if somebody creates a completely new resource, Terraform won't give you like a hey heads up, like, hey, there's a new resource here. So because the Terraform isn't aware of your entire subscription, it is just aware of the resources that you tell it to be aware of. But if there is a new resource created manually, you can import it to Terraform. But we cannot go through it in the next 14 hours, unfortunately. But that would be something we would do in a pre-con even. And also Terraform also has this Terraform state backup file to kind of see when you make the change, so that if it goes kind of errors halfway through, it knows how to return to the previous state. All right, so that's there. And if we look to the portal, we should now have an updated situation in our resource group, as long as I can find the refresh button. There it is. So very nice. It appears automatically. So let's take a little, I have a bit longer files here. Let's grab this resource. Even though it feels like there's like a bracket missing there. But anyways, let's fix that. So this is our SQL resource here. I'm not sure if we have time for that, so let's put just our password in here. Hopefully it went according to the password requirements for SQL. So again, a very similar kind of resource block. We start to see the same patterns: resource block, the resource type, and then a name for it. And if we look at this configuration, we have again a reference to the resource group for the resource group name. Let's switch this to also be to the resource group location. So we grab the location from the resource group and not Sweden. And then we give the version and then admin login password. We'll talk about the password in a bit. And then we have also the SQL database. With the server, we don't really do yet anything. So again, a database, a reference to the SQL server that we just create here, so that the database is actually created within the same one. So 2 simple configurations to add. You noticed here, I already have a variable environment name. So let's say we want to kind of take the same template for the names as we have in the storage account already. So let's create a variables.tf file here to handle our variables. And surprise, surprise, we have a variable block. And we can call this end name. And then we can give it, for example, type. Type is the correct one here. So this would be string. And then default. Let's give it this value. But let's say we want to have a little dash there for our other resources than the storage account. So with that, if we put that in place, normally this turns it red. Yes, that looks better. So with this, we had actually a reference already in this SQL. We had a reference to the environment name. So this is how we are able to interpolate string values. So we just put our string value that we want in the beginning, and then we reference the variable by the var dot the variable name. And then if it's within a string, we just need to have the dollar and curly brackets there to make it part of that entire string value. So let's do the change for the storage account. So basically we want to replace this part. And yes, and name is the one that we want. Are we going to have some issues? It's maybe a little bit of a leading question. Slightly. So of course, with storage accounts, we have some requirements on the naming. We cannot have dashes in there. So we can actually have there's a bunch of different functions in Terraform that are available. And one of them is replace. And actually, when you're writing it, it does give like a short description of what it does. So it can be beneficial to use it, but a replace, you can just take the variable, take the dash out and replace it with nothing. So that way we maintain the same storage account name. And so even though we changed the Terraform configuration a little bit, but the outcome is the same. So it won't actually then try to recreate the resource because it keeps the same configuration in the end, even though the way to get to the configuration is a little different. So if anyone likes to be a little clean on their files, you can run format either with the Terraform, FMT, or just regularly format, and it will align the equal signs, for example, for you in a nice way. So if you like things to be nice and aligned, that is one way to do it. So let's do an apply. I could have run a validate actually. So one way to ensure if you make multiple changes and to check like, did I do that right or did I maybe do a typo? There's a Terraform validate command as well, and that will help you to ensure that the syntax is right. It won't check like, are the values right for Azure, but it will check, are all your references in Terraform correct? So that is oftentimes a nice thing to just check out and ensure that you did everything right if you do many, many changes at once. So we see we have the SQL server, and then we have the database as well. So you can see that oftentimes there is quite many other settings behind the scenes as well that it will then just take the default values for if you don't specify anything in the Terraform itself. All right, I think we can leave that running for a moment. And I see there's a question about the source code. I haven't pushed it yet, but I can push it out after the session. I have my own GitHub, and I can get the link once we finish. So as we're creating that, we noticed that we put in a secret into the values. So I want to show you how Terraform handles secrets. We don't have much time yet anymore, so I will just this is the main downfall of Terraform at this point, in my opinion. What makes Terraform not in all cases the best thing to do. So we are creating our SQL server, and yes, nowadays there is actually a way that you can disable the SQL login and just use Azure AD credentials. And that would, of course, solve the issue that we don't need a secret in our Terraform configuration. And the other option would be to put it in a variable and then have yourself pass it in as you do the Terraform apply. So you can then say, hey, this variable SQL secret is this value. And so in a pipeline, you could just pull it from one of your secret stores, for example. But there is still an issue as long as like Terraform is writing that value to your resource. What happens is, unfortunately, is that it ends up in our Terraform state, which is not ideal. And I think this might be locked, so I'm not able to open it quite yet. But once we look at this in a moment, once the process is done, you can see that Terraform actually locks the state file, that it's not possible for two people to be poking at it at the same time, or two processes to be poking at it at the same time. So there's not like overlapping changes that cancel each other out. But the point is here that if we pass a secret through Terraform, it will end up in our state file. And that kind of makes it so that if we do have secrets, even if we put them into like some secret store and pass them in a variable, they will still end up in the Terraform state. So what often happens is either you have to find a way to, within Terraform, just pass in an initial secret value and then replace it by another process. I think that is the most common scenario. Or then the other aspect is that you protect your state file just as if it were some kind of secret, and you hold it just as securely as you would any of your secret stores. So that means that you would then have it in Azure storage and have network controls in place, plus access control in place, etc., and monitoring as well, so that you can tell if there's been any weird activity happening with your storage account. All right. The SQL takes a little bit of time to complete, but secrets end up in your state files if you pass them through Terraform in any way or form, whether they are in your Terraform configurations itself, which they never should be, or whether you pass them on the fly somehow. They still end up in your Terraform state. That is what you need to remember. All right. I do think I have to move on to the next portion here. Let's wrap up by quickly looking at the full workflow, because yes, you might start your Terraform configurations on your own and just create something and get happy and create your resources and things work. But as you saw, I had that Terraform state file on my laptop now, and that's not very functional if I want to work with a team. So I have to be able to put that state file somewhere, wherever that be. And this is called a remote state. And one of the options, as mentioned, is to host that in Azure storage. So you can create a regular storage account and create a container and then point your Terraform configuration there. Hey, use this location as a remote state location. And that would then, of course, mean that other developers can actually access that from their computers as well and make their changes to the Terraform files as well. So you want to completely move it from your own location. The other aspect is, of course, then the Terraform files themselves. It doesn't really work if you just keep them on your computer. So what we need is some kind of version control. And to kind of version control on your own laptop, you need Git. And then you need some kind of central repo that is remote for other users also to access, to host the files in a central way. And there we have, of course, many options: GitHub, GitLab, Azure DevOps, and so forth. There are quite limitless options nowadays for where to host your Git, or those kind of the remote Git. And so if you're the person who has gotten everything started and you want to push your code to the central repo, you would start with initializing the folder where you have all the files, and then you would add this remote URL, this remote central repo, to that directory that, hey, connect with this central repo. And then you would be able to continue with the development process. Or if there's already files in some central repo, then you would, of course, pull those changes and clone that repo for yourself on your computer and get started. So there is a lot of detail to how to use Git and everything, but I just want to give you the general overview of the workflow. So don't worry if you don't get all the details here. So how you then would go about making sure that you don't step on each other's toes when you're developing something is that you would create yourself your own branch, and then you choose that, hey, I actually want to work with this branch. So the checkout is actually how you move into that branch and start working on the files. So branch just creates a copy of the main set of files and makes another copy of it so you can make changes to it without affecting the first set of files. So what it could look like is that you have kind of these first changes done, and then you make a different branch out of it and a different copy where you start working. So then you create your new Terraform file, for example. Then you need to tell Git like, hey, start tracking this file. There are changes over there. And then you want to make some kind of commit to say, hey, this is the kind of changes that I made in my file. And that means that in your branch now you have kind of new changes that are not in the main branch where you started off from. So you are now ahead of it. And so to kind of get your changes into the main branch, you would need to do a pull request would be a good idea. For example, in GitLab, that is called a merge request, which in a way does kind of make more sense, but kind of the established term is pull request. And there you could have then maybe some people check your pull request, have even some validations in place before it can be merged into the master. But in this way, if you use the branching, then you are able to even have multiple people working on the different parts of the files at the same time, or even same parts, but then you need to do maybe some rebasing and things like that before you merge things in the end. So yes, and then the last step, you push your changes to the central repo. It is a little simplistic, so that's not all the details, but gives you a little bit of an idea of the workflow. All right, I'm only 1 minute over time at this point. So we started from an introduction to infrastructure as code. Then we checked how you get started with Terraform and how you set variables and what happens to secrets when you put them through Terraform. Doesn't matter if they're in your code or not. And then lastly, we did a swift walkthrough of how does the workflow change when you do use Terraform. And lastly, before, just to emphasize this secret thing, our changes went through. We have our database in there and server as well. If we now look into the Terraform state, we have the database. We have, trying to find the correct spot, the SQL server. Here is the login password in plain text. So hold your state files like secrets. This is what you should remember from it. Excellent. So, and if we do go back to our Azure portal and check like, hey, are all our resources here? Yes, they are there. Perfect. So of course, starting with infrastructure as code can take a little more time than going into the portal and clicking around. But then once you have the configuration, it is really easy just with a few commands to get your resources up and be up and running. So a lot of times when I do any demo environments, I have Terraform scripts for them, so I can just easily get them up whenever I need them and then destroy them after I'm done. So thank you so much for joining. I hope you learned something new today and you found this interesting. And if you do have any questions, now I lost my mouse, there it is. If you do have any questions, you can find me both on Twitter and LinkedIn for now with my own name. So if you want to reach out, feel free to do that. It would be lovely to connect. That's it. Thank you so much. Thank you for having me, Magnus.
Thank you for coming. You didn't switch to Mastodon then, like?
Not yet. I'm kind of like, probably will be there soon. So
I've got an account in both, so it's just twice as complicated to communicate with people now. So
yeah, exactly. Yeah, that's kind of my thinking as well. Like, I'm not sure if I want to make it so complicated, but let me also now, while I remember, get the GitHub link into the chat as well while we're wrapping up.
Yeah, well, I was trying to help you with it, but my Google foo wasn't good enough today.
Yes, let's see. Yeah, I'll push the changes later today once I get off work, and you'll find them there to fetch. So great.
Kiitos from Patrick Nilsson. Yeah, and from me. It's one of the few words I know. I forgot how to say cheers.
I hope that link is, yeah, that's right. Surprising, it's again just my name in the end of github.com. So
it was that easy. Okay.
Yeah, exactly. And Yeah, you can actually find there's the most up-to-date, like if you're interested to get into hands-on exercises, there's a Datamines Terraform folder there as well that has actually hands-on exercises that you can walk through yourself if you have an Azure environment available. So feel free to use those and learn on the way.
All right. So for
Yeah.
well, thank you for coming, and for everyone
You're
else,
welcome.
well, follow Heini on Twitter. You'll get the news on where she's going and stuff like that. If you want to see Heini speak on an event in person, or if you want to join a pre-con, and
Yeah.
do subscribe to Knee Deep in Tech. It's a combination of fun and tech. So it's a
Yes,
it's
definitely.
a podcast for anyone who didn't know that, but. You're on episode something like 1 million or so. So
216 was the latest.
yeah, that's the closest to 1 million I could get. Yeah. So
Quite close.
and you've been around since a year or something in Knee Deep Tech?
Must be like almost a year and a half now.
All right.
Yeah, getting close to that. I started sometime in September, like over a year ago. So little over a year, close to a year and a half.
It's kind of
Time
cool.
goes fast.
It's not easy to make a podcast and be consistent with it, but what's cool is that the infrastructure around them it's very easy to access, and it's easy to publish once you still have to create some content for it. But as soon as you do it, so for everyone, if you have Spotify, which I guess 99% has, it's there.
It is there. Yes.
And it will tell you there is a new episode. So I don't even have to know you publish an episode. It's perfect.
Yeah, that's nice.
So I'm gonna go back to getting paid somehow.
Yeah.
Thank you for coming.
You're welcome. It was really fun. Thanks for having me.